Thank you for participating in Morehead at Home Sky Watching, hosted by Morehead Planetarium and Science Center. My name is Amy Sale. I'm an educator at Morehead. We are a unit of the University of North Carolina at Chapel Hill, located on campus. We also work throughout the state through a number of outreach initiatives like our mobile lab van, summer camp programs, and the annual North Carolina Science Festival. Our mission is to help people better understand science, technology, and health, and we do this through engaging programs like this live virtual event. So we're glad that you're here for our program on the constellations of the Zodiac, and my colleague Nick will get us started.
Hey everybody, I'm Nick Eakes from Morehead Planetarium and Science Center. I'm an astronomy educator. We're excited to have you with us today from Morehead at Home. So if this is your first time tuning in with us, here's how it's going to work. What we're going to do is share our screen and use a kind of flat screen planetarium software called Stellarium that's going to help us to simulate the nighttime sky. So if you're interested in this software, you can actually find it for free at stellarium.org. And that way, maybe in the future, you can follow along yourselves. So what I'm going to do to start us off is share my Stellarium window. But I wanted to let you know that if you have a question, whether it's about exactly what we're talking about or just something you're curious about, please use the Q&A function down there at the bottom of your screen to type those in. And then after our presentation, we're going to take some time to try to answer your questions too. So be curious, ask good stuff, and we're excited to answer. So for now, let's get a look at our sky. So you should be seeing a kind of funny round window that shows us our daytime sky. So we have a couple of things in the daytime that we are going to talk about, but we're going to help you pull an all-nighter first before we do that. So our first step here is to move time forward. If you want to follow along during this lesson, a really important place to look is right down here where we have a clock. So you notice it's moving faster than a normal clock, and that helps us to kind of manipulate space and time and show you some things as they would look tonight. So if you live in a place where it's kind of stormy outside or kind of bad weather, some of the lessons we'll teach you today will still be applicable on future nights. So don't worry if you have a bad forecast for this evening. So as we move forward, you notice the sun is in the sky. You might also see a label for the moon. Well, we'll talk about both of those objects in depth in just a little bit, but first we have to have that sun set. So as it gets closer to the horizon, we see the glow and we get a look at a nice dark nighttime sky. I moved us to about 9:30 p.m. If you're watching and that happens to be past your bedtime, that's okay. Using a software like this or even going out a little bit earlier, you should still be able to see some stars, but that sunset glow is definitely still present. So we told you we were going to talk all about the constellations of the Zodiac. But first, I think maybe we need a refresher or a reminder on what a constellation is and how to find one. So what I'm going to do for us is help you find a very familiar constellation and very familiar pattern in the sky. Many of us have probably seen it before. It's called the Big Dipper. Now, I kind of misspoke because the Big Dipper itself is actually part of a larger constellation. The Big Dipper that we know is technically called an asterism, which is just a familiar grouping of stars. So that familiar grouping contains 7 bright stars, 3 in the handle and 4 in the bowl, and it makes it look like a big soup spoon that you dip into a pot of soup. So look around for just a moment. See if on your screen you can pick out this soup spoon or this Big Dipper. People have also seen it as a drinking gourd. I kind of see it as a brontosaurus or something like that, but use your imagination, look around for a moment. In just a second, I'll use my pointer here to help us find it. If you caught it, it's right up here, kind of at the top of our screen. 3 stars in the handle and make an arc like this, 4 stars in the bowl, and this is our Big Dipper. So I can help us out just a little bit here and bring up the full shape of the constellation that the Big Dipper is a part of. So you notice that there's more than just those 7 stars connected here. This entire shape is called Ursa Major, or the Big Bear. And if you're having a little bit of imagination trouble, there's the rest of our bear. I know we see a friend poking up over here. We'll talk about him in a little bit. What I'm going to do now that we've identified this constellation and maybe even learned a little bit of the difference between an asterism and a constellation, I'm going to pass it over to my friend Amy and tell you a little bit about how this relates to our lesson today.
Okay, thanks, Nick. So we've been talking about what a constellation is. And, often when you think of constellations, you think of these star pictures, these connect the dot outlines and the artwork. And of course, when you go outside on the next clear night, you're not going to see any lines connecting the stars, and you won't see any pictures of bears or any other pictures. And astronomers think about constellations differently. To astronomers, a constellation is an entire area of the sky. So Nick just added some boundary lines to show you the area of the sky that is called Ursa Major. And even though it looks like there's sort of a method to the madness, the way the lines kind of jump around, this is arbitrary. Constellations are human inventions. They are not based on natural groupings of stars. We could have made up totally different constellations if we wanted to. So when something is in a constellation, it doesn't necessarily mean that those stars are close together in space. It doesn't necessarily mean that they're gravitationally interacting. They can lie at all different distances. It just means they're in the same direction. And astronomers have divided up the sky into 88 constellations. They're like puzzle pieces. Nothing is left out. And Nick is showing you a view of all the constellations visible in the early evening from our location in central North Carolina at this time of the year and this time of the night. So when you're looking at things that are really far away, like stars, the stars that you see at night, they don't appear to move relative to one another over short periods of time. And astronomically speaking, a human lifetime is a short period of time. Even a lot of human lifetimes is a short period of time in the grand scheme of things. So the same star patterns that you see tonight or on the next clear night, they're pretty much the same star patterns that our ancestors from long ago have seen as well. Okay, now get ready, because in a minute or so, we're going to have a poll question, and I'm kind of hinting at some of the answers to some of the poll questions, to one of the poll questions. Okay. So let's talk about what it means to be in a constellation. So you'll often hear people say something like, oh, Mars is in Sagittarius or something. What does that mean? It just means that that object is lying in that direction of the sky. It doesn't necessarily mean that that object is anywhere close to the stars in that constellation. So let's go ahead and pop up our poll question, if we could, the first one. Okay, and let's take a look at this one. I think this one is a little tricky, and it's asking you to answer which one of the following three options is true. First, from a given location, you can see the same planets in the same places in the sky every night. If you think that is true, then you would want to pick that option. The second one, the sun, moon, and planets all appear to move against the background of the stars. If you think that is true, pick that one. And then the third option is the sun always appears to be in the same place relative to other stars. So if you think that is true, pick that one. And we'll give you a little bit of time to think about your answer on that one. And I'm going to give you a hint. Things that are close to us, say in our own solar system, will appear to move against the stars. Things in our own solar system are relatively close to us, so we can detect their motions. Okay. And you've got less than 30 seconds. Feel free to discuss with anyone who might be around you. And when our tech people are ready, they will pop up your answers. Okay, Nick, what do you see?
All right, so it looks like The overwhelming favorite was the second option. The sun, moon, and planets all appear to move against the background of the stars. We had a couple votes for the sun always appears to be in the same place relative to other stars. And it looks like 0% chose the first option. From a given location, you can see the same planets in the same places in the sky every night. So which one's right, Amy?
Well, it was that middle one. So many of you got it. The sun, the moon, and the planets do appear to move against the background of the stars. So everything's moving. It's just those other stars, the stars other than the sun, the ones you see at night, they're really far away. So you're not really going to detect their motion relative to one another. Certainly not over a given night. Now, the sky as a unit will appear to move over the night, and that's because of Earth's rotation. Okay, so let's take a look maybe at, we talked about how the sun, the moon, and the planets can all appear to move against the background of the stars. Let's focus on the moon first. So everybody look around at your screen right now and see if you can spot the moon. It looks like it's hanging out in the direction of the constellation Cancer. And the moon is very close to us. It's our only natural satellite. It's within our own solar system. The stars in Cancer are not in our solar system. They're in our galaxy, but they're really far away. So the moon is nowhere close to the stars in Cancer. It just lies in that same direction of the sky. But let's see what happens as we advance through the nights. I wonder if, Nick, if you could do some time travel.
Sure. This type of time travel might be a little different than the time travel we already did. Before, I was kind of simulating how the Earth rotated and how things appeared to move across the night. But maybe let's get a look at how the moon appears in a different place from night to night. So maybe how it looks tomorrow and the next night. And in Stellarium, you can do that by using a couple of hotkeys to change your day, basically. So keep an eye down here on our date. Right now, it says 2020. 0430, that's right now. If I move forward one day, check out how that date changes and check out how the moon's position changes. Here we go. We're going to stay right here at about 9:39. Here we go. Okay.
Oh, look at that.
You might have noticed it changed a little bit. I got to adjust something here for us so that we can still see these boundaries because I think it's pretty important. All right, we moved one day. We're in May now. Happy May. Let's move forward another day.
So we move from Cancer into Leo, continuing to move through Leo.
Next day.
And again into Virgo.
Next day. This is the 5th of May now. We're in Libra on the 6th of May. 7th of May. And maybe you can even tell that the moon is changing its phase. I know it's not a big zoomed in view of the moon, but maybe you can tell that it looks a little different. And then on the 8th at this time of night, we don't even see the moon anymore. So let's go backwards just so you can see. The background stars are appearing to stay in the same place, but the moon's position changes. And you might see a little jerk and a little shift. That's because as our days change, those positions will look a little bit different, but you notice the patterns stay pretty much the same.
And I don't know if anybody is happening to notice as Nick moves the moon around because he's advancing the days one at a time. There is something else in the sky that also appeared to move relative to the stars. It was much more subtle movement than the moon's movement, which is really obvious from day to day, from night to night. Nick is circling it. Venus actually has been moving. If you've been watching night after night after night, it has been moving through the constellation of Taurus. And you might have actually noticed this. If you pay attention, it's a much more subtle movement than the moon, though. So the planets also move relative to the stars. Okay, Nick is rewinding us in time. Now forward again.
Yeah, you probably noticed it's very subtle compared to the moon, but it is not staying in exactly the same place.
So, and the word planet comes from a Greek word that translates to wandering star. Planets are not stars, but the ancient Greeks, among others, noticed that planets appear to move relative to the background of the stars. That's one way that you can tell something is a planet. Okay. Planets don't move just anywhere relative to the stars. We'll get to that more in a moment. But Nick, I wonder, would this be a time that we could pull an all-nighter? Because we're only seeing Venus. We might want to see some more planets.
Yeah, absolutely. That's our specialty, pulling all-nighters. So Venus is the only planet as of right now that you can see in the early evening, but as we can control space and time, we're going to move you forward. Look at how these boundaries kind of stay the same as we do this. But we're going to take you to the early morning. If you've tuned in with us before, or if you're just an early riser, you might have noticed there are some kind of interesting sights up in the early morning sky, and you're starting to see them rise now. We're going to probably pause right here at about 4 a.m. I know that seems like a time that nobody really wants to be awake, but astronomers do wild things like that. We stay up so that we can see some interesting sights in the morning. So we are here at about 4 a.m. And the things you might have wanted to notice are three planets: Mars, Saturn, and Jupiter.
And by the way, somebody asked in our last session if you had to go out at 4 or 5 in the morning to see these planets, and you can go out a little bit earlier. Jupiter and Saturn are both rising by 2 a.m. now. Mars is rising around 3 a.m. But if you want to get them, higher in the sky, it does help to go out a little more at 4 or 5 in the morning, at least right now. They are, generally speaking, rising earlier and earlier each night. And then, Nick, could we go through some more of your special time travel?
Absolutely. Let's put our idea about how planets move to the test. This time, you see the moon's not up in the sky. Keep your eye on these three planets, and I'm going to move us through a couple of days here. Let's move forward in time first. We'll go further into May and see how these are going to change. So keep your eyes on the planets here. 1 day, 2 days, 3, 4.
Oh, there comes the moon again.
Yeah, the biggest light polluter of them all. You will still be able to see the planets, even though the moon could be close to them. So check it out. What do you notice?
Now going backwards. Do not try this at home.
Yeah, breaking all the planetarium rules. Hopefully you noticed that these planets appear to be moving ever so slightly as well. Maybe Mars is appearing to move a little bit more than Saturn and Jupiter. We can try it one more time. There we go. So I know I'm moving forward and backwards kind of quickly, but the idea is that we don't usually get a look at the same spot over the course of many days. Imagine you're setting up a camera facing south in your backyard, and you take a snapshot of the sky every night at this time. That's kind of like the picture we're making here as we jump day to day.
Oh, that's a great point, Nick. Yeah, we don't want to leave you with the impression that Mars is suddenly going to jog to the left, relative to the stars in one night. This is, again, night after night after night. And Mars moved. Yeah, go ahead, Nick.
I was just going to say, Amy, why do you think that Saturn and Jupiter don't look to be moving quite as much as Mars?
Yeah, I had a lot of trouble detecting actually their motion, even though I know that over this year, they're actually going to look like they're pulling closer together. And they're not in reality, of course, but not by any noticeable amount, but they'll look like it. And they orbit farther out from the sun than Mars does and than we do, and they take a long time to orbit the sun. So the effect that we see is that Jupiter can take about a year to work its way through a given constellation, and Saturn can take about 2 years to work its way through a constellation. So Saturn and Jupiter have been hanging out in roughly the direction of Capricornus and Sagittarius for a while now. So that we've seen how planets move, but we also mentioned it's not just the moon and the planets that appear to move against the background of the stars and the constellations, but the sun does too. So maybe we can complete our all-nighter.
Yeah, do a big stretch. You just stayed up all night with us. Here we go. The sun's rising. And you notice that even though you can't see the stars anymore, those boundaries are still there.
Right, that's a great point. So the sun can appear to be in front of different stars. Now, you're not going to actually see those stars. Like, by definition, if the sun is up, first of all, you shouldn't be staring at the sun, and you're not going to be able to see the other stars, but they are there. And Nick, what does that look like to you? The sun is currently in front of Aries, the constellation of Aries. Interesting. Okay. So, oh, and there's the path of the sun. So Nick just added the ecliptic is what that is called. That's the path that the sun appears to take in front of the stars over the year. It's the apparent annual path of the sun. And Nick, could we, before we pop up our poll questions, so everybody get ready, there's going to be a poll question. Could we maybe run through some annual motion and see how the sun
Sure. So
moves?
this is going to be similar to what we just did, moving one day at a time, but I'm going to make it go even faster than that. So if you really want to track what date we're on and where the sun is, keep an eye on your time and date down here. But we're going to go forward. Watch how things appear to move. We're going to try to stick right here at noon. So this is the noontime sky, but we're just going to change the date. Here we go.
And while y'all are watching, notice the constellations that the sun appears to pass in front of and see if any of those constellation names look familiar to you. You're also seeing the moon whiz around as well. You must be getting towards winter when that sun seemed to get really low at midday. Okay, so
That was just about a whole year.
Oh, a whole year just went by. Excellent. So we're back in Aries here in late April. So I wonder if we could pop up our poll question now, because that was kind of weird. It sort of looked like the sun was orbiting us. So which in reality, which orbits or goes around which? Pick one of these. The sun orbits Earth, or does Earth orbit the sun? Pick which one. And I think we'll just give you a little bit of time on this one. So in reality, which one? And while y'all are thinking, I noticed a question, somebody noted, Caroline, I can't see Saturn move, but I see Mars and Jupiter move. Is Saturn just too far away to see, or is the movement just extremely small? You can see Saturn with the unaided eye. It's just that it's moving so much more slowly, apparently, against the background of the stars that it's just difficult to tell. Okay, and I think we're gonna pop up the results. All right, 96% of you said that Earth orbits the sun. That is correct. Earth orbits the sun. I know it looks to us like the sun goes around the Earth, and because it seems like that must be the case, that's why people were confused about that for so long. But we now know that Earth orbits the sun. And look at those constellations that the sun appeared to go through. Those are the constellations of the zodiac. The ones that, like, if you pay attention to sort of your newspaper horoscopes, they might seem familiar to you. And you might even think of particular dates being associated with particular constellations. You know, for example, if your birthday is around now, Nick and I both have birthdays around in early May, you might think, wait, isn't Taurus, the bull, supposed to be associated with right now? Well, if you looked, you saw that, in fact, the sun is in front of Aries now. So those dates are wrong. So here's the deal. Astrologers divided up the sky into 12 equal pieces, but the sun does not spend exactly 1 month in front of each constellation. So, like, take a look as we head towards Virgo. That's a big constellation. The sun takes about 6 weeks to work its way through Virgo, and it takes much less time. Oh, look at that. It's going through a constellation called Ophiuchus, and it went through Scorpius and took like barely a week to get through Scorpius. So that's one reason why the dates don't line up. Also, the astrologers set up their system a really long time ago, and things have changed. Earth has several motions. It rotates, creates day and night. It orbits the sun, that creates the year. And it also does something called precession, which has a couple effects. One is that it changes over very long periods of time, the star that we best call the North Star. It also changes the dates that the sun appears to be in front of different constellations. Okay, so why should you care about any of this? Well, there's a scientific reason why you should care. It can help you find planets. because this ecliptic, it's not just the path that the sun appears to take over the year. You can think of it as a projection of Earth's orbital plane out into space. That is a representation of Earth's orbit, of the plane of our orbit. The other planets orbit the sun more or less in that same plane. So you're always going to find planets on or near the ecliptic. In other words, you're going to find them in or near zodiac constellations. That's why it's worth your trouble to learn zodiac constellations, because that's where you're going to find planets. And I know, Nick, we're almost out of time. Do you think we have time to go back to a nighttime sky and just confirm that, in fact, we saw the planets?
Sure.
The
So let's
zodiac
do that. I
constellations?
just hopped us back to today really quickly so we could be accurate here. And I will super speedily zoom us forward in time. So when I moved us back to today, it went to right now. So of course we have to wait for the sun to set again, but keep your eye on that ecliptic of date line. You notice the moon is pretty close to it and hung pretty close to it as we moved through those years really quickly. But watch. Remember, the first planet that you're going to see in the early evening is Venus. So keep your eye out for Venus. And we'll just keep it at this speed right here and roll through one more night. So you guys are extra special today. You get to spend 2 all-nighters with us. Here we go.
And if y'all, I know the weather doesn't look super great for North Carolina tonight, but on the next clear night, if you haven't seen Venus yet in the early evening sky, make sure you see it. It's really, really bright. And then we're gonna head to the early morning sky to pick up Mars, Saturn, and Jupiter. And remember, planets move against the background of the stars. And also we're moving in our orbit around the sun. So, Venus is visible in the early evening right now. That's not always going to be the case. Mars, Saturn, and Jupiter, not always going to be a 4 a.m. kind of experience for you. Sometimes they're actually up in the evening. You're going to have to wait a while, though. And there they are. And you can see that Jupiter's in Sagittarius and Saturn, Mars in Capricornus. And that's what astronomers call it, by the way, Capricornus, not Capricorn. And there we are. So we only have a couple of minutes left, but I want to see if we have any questions. Anybody's got? Nick, I see a question about, if you are into your whole what's your sign thing, when's the best time to actually see that constellation? Like Nick, the astrologers would tell us that Taurus is our constellation, but is this actually the best time to see Taurus? What do you think?
Not exactly, because those constellations of the zodiac, as we kind of mentioned, line up to where the sun was on the month of your birth or close to it. So if the sun's in the sky, can you see the stars in the background? Not really. So I always look for Taurus about 6 months or half a year from my actual birthday, and then it should be high overhead in the sky. So it's always opposite time of the year. So I know on your birthday, you might want to see your favorite constellation in the sky if it's your constellation of the zodiac, but that's not when you're going to see it because the sun is in front of it.
Yeah, in fact, Taurus is a winter constellation. It is best seen in winter. All right. Nick, do you see other questions that we have time for?
Sure, I see one that's somewhat related, and I think it's a really good question. Why is the sun so hot? On Tuesday, we talked about vacation destinations in the solar system and talked about maybe why the sun is not such a good vacation destination. Why is the sun so hot, Amy?
Oh my gosh. Well, it's got a lot of mass, and there's a lot of really high temperatures and pressures, and it's fusing hydrogen and helium, and it's creating all this heat and light. That's what stars do, by the way. They create light. And I see a question, which I'm going to relate to it. And this would be probably the last one we have time for. How long is it to go to Neptune? I'm going to make a shameless plug. We just published a blog post inviting you to take a walk from the sun all the way to Pluto, which would include Neptune along the way. And this relates as well to the session we did on Tuesday, vacation destinations in the solar system. So if you've been feeling like you've been itching to travel, take a trip through your entire solar system, just in your neighborhood. And if you go to the Morehead Planetarium blog, you can find more instructions and a link to an activity to do that. And all you need are your feet and whatever objects you might have around your home to represent the sun and the planets. And that activity talks a little bit more about the sun being so hot and what it'd be like to visit all those places. Let's just say it'd take a really long time to get to Neptune if you were going in a spaceship.
Okay, well, that looks like all the questions we have time for today, but thank you all so much for joining us. We're going to be doing these Morehead at Home sky watching sessions on Tuesdays and Thursdays at 10 a.m. So join us next week. We'll talk about some other topics in the nighttime sky. And if you have, last minute questions or anything like that, feel free to drop them in the Q&A or the chat, and we might take a second to look at those. But if you want more information about virtual programming from Morehead, please check out our website at www.moreheadplanetarium.org. And you can follow us on social media, whether that's Twitter at Morehead Planet or Instagram, Facebook, YouTube. You can search for Morehead Planetarium there. So tune in next Tuesday. We'll see you then.